This is topic 1, introduction. The content are as follows. What is hydraulics and applied hydraulics? Application of hydraulics, examples of hydraulic engineering, methods used in hydraulic engineering, features of flows in hydraulic engineering. First, what is applied hydraulics, or what is hydraulics in the first place? Common use of this word hydraulics is to mean machines that use liquid to transmit forces. It is contrasted with pneumatics, which use air pressure to transmit power. We do not mean these machines in applied hydraulics. Then, what do we mean by applied hydraulics? By hydraulics, we mean the study of physical water or similar liquid, not necessarily chemical H2O, in motion or at rest. Hydraulic engineering is engineering that controls distribution and movement of water for living, for agriculture and industrial purposes, and for safety and good quality of human life and the environment. Then applied hydraulics is the knowledge of hydraulics applied in hydraulic engineering. Related subjects are, first, fluid mechanics, which is a study of fluids, liquid and gas, in motion and at rest, so is the basis of hydraulics. 2, hydrology, which is a study of water circulation on the earth, with emphasis on the rainfall. So it is the basis of hydraulic engineering dealing with water on the ground of the earth. Water supply and water resources, which deal with the collection and distribution of natural water for various human activities and is part of hydraulic engineering. Some of the examples of hydraulic engineering are shown here. First picture on the left shows a dam. Dams make use of water by controlling the surface water flow for various purposes, including water supply, irrigation, power generation, and flood control. The pictures on the right show examples that hydraulic engineering tries to prevent to happen. The water hazards such as inundation due to excessive water or drought due to lack of water. Also, hydraulics is applied to preservation of nature and ecosystem. In addition to these, hydraulics is applied to enrich life. Some of the specific examples are listed here. Construction and maintenance of hydraulic structures to control flow of rivers, canals, and coastal currents. Construction of water supply and wastewater disposal systems. Construction and operation of hydropower facilities. Protection of river basins from floods and droughts. Protection of coasts from erosion due to waves and tsunami, etc. So applied hydraulics, in short, makes use of the knowledge of hydraulics to utilize water, control water, and preserve environment. There are a few different methods used in hydraulic engineering. The first is the semi-empirical criteria based on the past experiences and knowledge, such as safe flow speed and depth for natural rivers. The second method is to make use of principles of fluid mechanics, such as momentum and energy principles, to estimate flow quantities and required sizes and strength of structures. The third method is to make a scale model, such as a small model of a dam, to test the intended functions of structures and modifications, such as the spillways from a dam. Then the fourth method, which is developing with the advancement of computational techniques, is to simulate the effects of planned structures by numerical simulation. In this course, we cover all these methods except for the third one, the model testing method. The methods mentioned in the previous slide need to be selected and developed with attention to the special features of the flows and their motion in different applications. Many of the features can be explained and dealt with by basic fluid mechanics, but with special attention. They show distinct differences from other engineering that also make use of fluid mechanics. First, many flows in hydraulics are natural in very complex conditions. They involve motion of water in the presence of other materials such as soil and plants on the ground, man-made structures such as dams and tunnels in which water is stored or moved, and are constructed in various natural situations. If we summarize the features of the flows dealt in hydraulic engineering, they are as follows. 1. The large variation of scales. The scales of areas to consider go from millimeters to kilometers, and the motion is a very complex convolution of all these scales. 2. Geometries are irregular and vary from narrow linear shapes like long streams to flat and shallow, like in reservoirs and coasts, to very complex three-dimensional regions around structures. 3. The motion of water does not occur by itself, but interacts with other materials, such as solid particles of sand, soil, and rocks, air over water surface, or entrained, interrupted by objects like trees and vegetation. 4. Then the motion changes with time of different lengths. Rapid changes within seconds to days, and very slow motions that take months. These features make application of idealized fluid dynamics not easy and not practical. Special treatment for different purposes are provided and used. These are some of the books on the subject related to applied hydraulics that can be referenced.